So, good afternoon, everyone. I'm here to give you a brief overview or some background information about a new tool for the swine industry that Boehringer Ingelheim has developed, Ingelvac Provenza, and I will go into some of the description here. So, looking at some of the concerns and really kind of detailing what Boehringer wanted to do in the development of a vaccine for influenza. Was to address many different aspects, and this is kind of a laundry list, if you will, of them. And first of all, it was recognized that there was quite a large degree of frustration associated with the current vaccines in the market being just inactivated products. These vaccines tend not to be able to address the concerns with new or emerging strains. There's a problem with reduced dosing. Poor timing of vaccination is associated with inactivated products because typically these products have to be administered after the maternal antibody wanes. So there's a monitoring aspect of it that it has to occur, and then they have to get the product in there and then administered as a 2-dose product. And also to try and address some of the concerns with the high use of autogenous vaccines in that never-ending circle of trying to catch up with the most recent isolate that's circulating in your barn or in your system. And then also, there's the concern with trying to break through that maternal antibody. If a product was able to do that, that would be something new and innovative for the industry that they could use as a tool and really not have to rely on that waning maternal antibody. And then finally, there was the concerns with VAERD or vaccine-associated enhancement of respiratory disease. I'll get into that a little bit here on the next slide. So I'm sure many of you have heard about VAERD. This has been highlighted by Drs. Amy Vincent and Phil Gauger in the past, and it's actually something we've also seen in some of our studies as well. So with this phenomenon, if the vaccine that's administered does not exactly or very closely match what's circulating or the animals get challenged with, you end up with a situation of enhanced clinical disease, which also includes an enhancement of microscopic lung lesions and microscopic lung lesions in the lung and trachea. So now, what is Ingelvac Provenza? So this product, Ingelvac Provenza, is developed as an intranasally administered live attenuated influenza vaccine, or LAIV. This vaccine itself offers protection against influenza A virus in swine, and it's labeled for use in pigs as young as 1 day of age or older. It is a single 1 ml administration that's given intranasally. The vaccine itself contains an H1N1 and an H3N2 fraction and has been so far granted label protection against H1N2 and H3N2. And one comment I will make down there in the bottom right, it says that this technology was developed in collaboration with Mount Sinai, and also the USDA NADC was another collaborator as well. So if we look at the structure of the virus, of influenza virus itself, I'm sure many of you are familiar with this, especially when we start talking about the H, A, and NA portions of it. But you can see inside there it really kind of delineates the virus itself. Of course, it's a single-stranded RNA, negative sense RNA virus, 8 gene segments, but these gene segments are not always swine-derived. You can see on the display there are some gene segments that can be of avian, human, or swine origin. But really the gene segment that we're focusing on here is that bottom one there, that NS gene segment, or the non-structural gene, which we'll describe a little bit more here. So what's the purpose of the NS1 gene segment? Well, in a wild-type infection, that virus infects a cell, is decoded, and generates messenger RNA and proteins. And one of the first proteins to be generated is derived from the NS1 gene segment, and this is really an interferon antagonist. So what this does, as a virus infects a cell, this interferon antagonist basically blocks the interferon or the innate immune system of the host immune system, and it really helps the virus, allows it more time to infect, replicate, and ultimately cause disease. So with Ingelvac Provenza, what happened is there's a truncation in this NS1 gene segment, which really allows the virus to still infect and replicate, but there is no interferon antagonist that's developed, so that innate immune response is still allowed to occur and really reduces the occurrence of disease in the host animal. So with that NS1 gene truncation, this is kind of an excerpt from the paper from Mount Sinai. This really starts to look at what level of truncation was needed. And what was determined was that the level of truncation is really dependent on whether the receptors or the receptor sequence is still contained and allowed to bind to the eukaryotic cells. So that's really kind of the focus of what and why the NS1 gene truncation was utilized for vaccine development. I've been asked questions before, how is this similar or how is it different from the flu mist that people have used? Well, the flu mist is a temperature-sensitive influenza vaccine, and last year the CDC had no longer recommended it for use in humans, but that actually changed last week. The CDC now does recommend it for use again, and the flu mist people have come forward and said the real reason behind that is that the isolates that they were using, once they were in the host immune system, they really didn't replicate to levels that were necessary to induce an immune response. And they have switched the isolates that are in there, and they actually grow to a higher level in that temperature-sensitive system. So, like I said, just last week, the CDC is now recommending the use of flu mist again. But again, this is separate from the temperature-sensitive with the NS1. So the final real benefit of Ingelvac Provenza is the route of administration. We really wanted to focus on how can we get this product into an animal, again, without the use of needles. There's always a growing interest in non-parentally administered vaccines, just to try to eliminate the possibility of needle breakage and anything like that would occur at the slaughterhouse. So with this vaccine, we're able to target the nasal turbinate cells to really induce that mucosal immunity that's necessary for protection, especially in a wild-type system. So what are the key benefits of Ingelvac Provenza? Well, you'll see in the next presentation that it does actually allow for cross-protection against multiple isolates. It allows for the vaccination of growing pigs as a direct means of protection versus the traditional sow vaccination. And the third talk in this little session will be the evaluation of the product in the face of maternal antibodies, and another colleague will present that data as well. But it also, and I think the bottom one is really the most important, it provides protection before pigs are most susceptible. You no longer have to worry about getting pigs into the nursery or into the finisher and waiting for that antibody level to wane before you vaccinate. They can go into those situations already protected and not have to worry about any disease occurrence. So with that, I thank you for your time this afternoon, and probably got time for a couple questions. Okay. Yes, sir.
I wonder if you could comment on the choice of the intranasal route, and if you've looked at oral administration and oral.
Sure. Yeah, it would be, especially if you're looking at mass vaccination, if you can put it in the water or something of that nature. We haven't looked at the oral route of administration. I thought you were going to go with what would happen if you give it IM, because that's usually the question I get. Good point. So, but no, we haven't really looked at the oral, but I think that's something that's still under consideration. Oh, gosh.
I guess I have one, maybe. So with influenza constantly changing, how do the regulations work to allow for kind of changing of vaccine strains to match what's in the field?
Gee, Abby, that's a tough one. So kind of there's a couple different approaches to that question. One is if Ingelvac Provenza is effective now, how long will it be effective? And that's, will it work against the virus that's circulating in my system or in my barn? And that can be somebody's career in evaluating all the different isolates that are out there and ensuring that we have cross protection. If there were to become an instance in the future where we would need to update the strains, the USDA, specifically the Center for Veterinary Biologics, or CVB, does not have a specific guideline for swine products yet. They do have one for equine that does allow for kind of an updating of isolates or strains. So it would be envisioned that we would be able to utilize that and simply update the the isolates that are contained within Ingelvac Provenza to allow for more protection.
Let's think, Mark.